So now let's do an example of threads using C++. So C++ has a built-in thread library, and you can see that we include thread. That gives us access to that library. So before we start, let's see a non-threaded version of the program we're going to write. And we're going to call this function count to 10 inside a thread. Now what this function does is it takes a parameter, and that parameter is going to be a number of tabs so that we can line up several threads and we can differentiate where the output is coming from. This loop prints some certain number of tabs, and then we print a number just like before. We have a loop that goes from 1 to 10. The other thing I did is to give us some randomness with our delay is I'm using this expression to calculate the amount of delay in milliseconds. More or less this will be around a second, but it also incorporates the number of tabs so that different threads, if they have a different number of tabs, will have a different delay attached to them. In our main, we see the random number generator, we call the function, and then we print that we're finished just before returning. So let's see what that output looks like. And you can see that about 3 tab spaces over, we're printing the numbers from 0 to 9. There's a slightly random difference between the amount of time it waits between each number. And you can imagine that if we called this several times in a row, it would increase the delay a significant amount. So let's go ahead and make this threaded. And I'm going to set the number of threads to be 6, and I'm going to use constant expression so that we get a compile time constant here. And what that lets me do is make an array of thread IDs. This, even though it looks like this is a variable, since this is a constant expression, the compiler treats that as a constant. So I am defining the size of that array with a constant, which is what's required by the C++ standard. So we're not going to do this anymore. Instead, we're going to create the threads, or several threads, and we're not going to do just one like we did with pthreads. We're actually going to create 6 because that's the size of that array. So 0 to less than num threads. Say TII, so for each element in the array. Actually, we don't need to call standard thread. We can just say thread because we're using namespace standard at the top. Then we give it the function that we want to call in the thread and the parameter to that function. So that's our loop. And then if you'll remember from when we did pthreads, we want to wait for all the threads to complete before we exit. And we're going to do the same thing here, or a similar thing, except that the function that we're going to call, and it's called join. So what this will do is go through in a loop, and then for each of those thread IDs, it'll try to join that thread ID, and this loop won't complete until all the threads have completed. So that should be ready to run. And so you can see we get random output all over, and each thread is in the same column because we passed the thread ID. Now, one thing you may notice that's a little strange is we have this 7 out here. And it's hard to see this sometimes. This might not actually happen on your computer. It depends on a lot of things, including how fast the computer is, the way it schedules threads, and luck. But you can see that it's not really, something happened with the way that line got printed out. And what happened is one of the threads started printing tabs, and then more tabs and more tabs, and they wound up printing at the same time. And so you had a whole bunch of tabs, and then it printed 7 and 8. So we want to stop this from happening. And the way we're going to stop this is using what's called a mutex. So I'm going to create a global variable. And if you'll remember, global variables are shared amongst all the threads that are spawned from that process. before it starts printing out, I'm going to try to obtain the lock on that mutex. So what this does is this will wait until it actually can obtain the mutex, then it locks it. And since I'm actually declaring this variable inside the for loop, it's a local variable. So each pass through the loop, once it gets past this line, it'll free that lock because this variable goes out of scope. You can also explicitly free it if you would like. So again, what this line is doing so this prevents the threads from writing over each other. So you can try commenting that out to see how it works on your machine. It may work, it may not. So since the output stream using cout isn't thread safe, meaning that other threads they're sharing that same resource and they can write to it and there's no prevent them from interacting with each other. By obtaining this unique lock, we can be sure that we're not only one thread can actually write at a time. And notice we wouldn't want to put this sleep inside the lock because then every thread would wait for the lock and then they would go to sleep and just basically sit there doing nothing holding that lock. But the output, we definitely want them to lock so that they don't overwrite each other. So let's see how that works. And you can see here everything prints in its column as expected because there's no overlap because we added the mutex.